All right, well, good afternoon or morning from wherever you're speaking or attending from. My name is Chris Battisto. I'm the current IT&I Committee Chair here at ESIP. I'm also currently working at the NASA Goddard Space Flight Center at NASA USGS, which is the Goddard Earth Sciences Data Information and Services Center as a UserNeeds team member. And I'm excited today to introduce you all to Vinny or Vincent Inverso, who is working at the Earth Science Data Information Systems Project, also at the NASA Goddard Space Flight Center, which he has been working at for coming up to 4 years now. Vinny has experience as a research assistant in applied AI at the University of Pennsylvania School of Medicine and cardiovascular epidemiology at the University of Cambridge, and has also worked as a software engineer at organizations like Clutch and TD. He's been involved with the NASA Harmony project for a couple of years now, and I'm excited to introduce to you all the Harmony project today that Vinny will go over. And additionally, I'm looking forward to having time for a lengthy discussion afterwards if you're all interested in learning more about this workflow or how that may be involved with potentially any sort of organization that you might have to see how we do things here at NASA. I look forward to answering any of your questions, and so does Vincent. So with that being said, I will go ahead and turn it over to you.
All right, thank you so much, Chris. That was a great introduction. Let me share my screen here. All right. So as Chris said, today we're going to talk about Harmony. What is Harmony and why do we need Harmony? So I'm going to start with actually what is a DAC? A lot of you here might be familiar with what a DAC is, but if you're not, I'm going to take a minute to explain it here. So a DAC is a distributed active archive center, and ESDIS, where I work, which includes DACs like USGS, they are archive centers that archive earth science data. They're distributed across the US. They are discipline specific. So we have a DAC that is specific to snow and ice. We have DACs that are specific to things like aerosols and atmospheric data. And the goal of ESDIS and the DACs more broadly is to not only provide the data, but provide it in a way that's easy for end users to work with, right? We want to reduce the time from a user downloading that data or accessing that data to doing research or applying the data or figuring out some interesting insights from the data. Let me go back here. So that's what's depicted here basically is we have DACs, they're archiving data. They have services that they're developing to help end users get at that data. And they're developing APIs, of course, for users to access those services. So ESDIS, the Earth Science Data Information System, it's a very complex system, right? We have things called enterprise services, which all of the DACs integrate with in order to provide cool services. So we have things called EDL, which does authentication. We have something called CMR, which is a metadata catalog that helps with search and discovery of this data. And so it's non-trivial for these DACs to integrate with all of these enterprise systems in addition to developing cool services on top of the data. And of course, these DACs are not just archiving a single data collection, right? They're developing these services for tons of different collections. And a lot of DACs, I said that they're discipline specific, but really a lot of them interact with a ton of different types of data, right? Whether it's airborne data or remote sensing data, right? So we have all kinds of data. Some DACs are discipline specific, but really they do a lot, right? They have lots of types of data. They have quirky data. So developing these services is especially complex due to all of the data complexities, right? So you can imagine this whole process or writing these services is very difficult. And if you're familiar with ESDIS, as I just described, it's not just one DAC. We have lots of DACs distributed across the US. So all of these DACs are kind of doing the same thing, right? They're all developing these services for their data collections. They're all integrating with EDL, integrating with CMR, providing APIs. They're kind of doing the same thing, but they're probably doing it in different ways, right? Because they have different data. These DACs are individual organizations, even though we're a nice, big, happy family, like they have their own ways of doing things. And so everyone kind of ends up with a different version of what this looks like. So most recently, if you've been paying attention at all to what's going on at NASA, we're making this big migration to the cloud. So we have these missions that are putting new requirements on our data. We have bigger data, we have bigger files. There are a lot of challenges that the cloud helps us adapt to looking forward. And it also helps us be more efficient when it comes to how we store the data, how we provide services, and all the software that we build around this. I mean, everyone's using the cloud nowadays. We have to use it too. We have to change and we have to adapt. And so what this means for these services is we have to take them from on-prem and we have to migrate that same functionality to the cloud to provide continuity. And at the same time, we have to develop new capabilities for these new missions that are coming online with different data formats, maybe cloud optimized formats. So this is a continuously evolving picture here. All right, so this is kind of the picture of where we are today in the cloud. And so I described how this is a really complex thing. Like, not only are we dealing with lots of different data types, we're dealing with many different DACs. They're all trying to figure out how to migrate to the cloud. So what if we took away sort of the common pain points that all of the DACs have to deal with when they're developing their services? So this is the idea behind Harmony, right? So um, as a DAC, I don't necessarily want to have to rebuild the same data services platform over and over 12 different ways because there's 12 different DACs. Like, I just want to focus on providing good services, good science algorithms, and sort of abstracting away the more computer sciencey bits that, like, I don't really need to know any science in order to implement. So this is kind of the idea behind Harmony. So kind of hard to see from this picture, but what Harmony provides is a platform for all of these data providers, all of these DACs to write services in a common way and put them on a common platform. It's built in a way that things are very composable. So if ASF develops a service and then JESDIS develops a service, those two things can be chained together potentially. So we're not reinventing the wheel every time someone thinks of a new functionality. So we've gone from thinking about like these distinct services that are maybe collection specific and DAC specific to thinking more about the functionality that we want to provide from these services and how can we efficiently compose those building blocks in a single platform so that we can implement things a lot faster. We can implement things in a common way. And again, the DACs can mainly focus on just the science aspect of things. Now, on the user side of this, the big benefit is if you're a multidisciplinary user, or maybe you're new to earth science and you kind of want to explore and integrate across different science disciplines, you have a single API that you can go to now. You don't have to learn sort of the way that one organization does services versus another organization. And that's sort of where the Harmony API, that common standard user interface comes in. Now, of course, we didn't want to just build our own custom API, right? We want to be standards based, right? So it would be great if people could come in and use the APIs and standards that they're already familiar with. They don't have to necessarily relearn everything from scratch. So if you're familiar with OGC coverages, WMS, WCS, or more recently, we've integrated EDR, the Environmental Data Retrieval API, into our system. You can use those APIs, and of course, that also provides better interoperability, not just with users, but programmatic clients. So if we want to interoperate better with other platforms across the Earth Data enterprise, that's a lot easier by using things like OGC, WMS, WCS, EDR, all of these standards. Let's see, next slide. And of course, like I mentioned, like there are non-ESDIS tools that integrate well with these standards. So ArcGIS, QGIS, these are standards we want to be using so that we integrate well with open science, and we're sort of pushing that forward. We also provide, as Harmony, this common Harmony service library. It's basically a Python library that helps anyone who wants to write a service write that service more quickly. So again, we're abstracting away as much as we can and just trying to get the service provider to focus on like the science logic and the core of the science algorithms, rather than like, you know, how do I integrate with all, you know, all of these other authentication systems, metadata catalogs, like abstracting all of that away. So you're just focusing on, I got my Python, I'm writing a science algorithm. And of course, it's a little more complicated than that, but that's kind of the goal. All right, and we see CMR and EDL. So we also have this thing called Harmony Pi, and that is more end user focused. And if you're a user, like primarily our users, they want to use Python. So we have this Python library that you can use with your Jupyter notebooks or your Python modules to access Harmony if you don't want to access it programmatically from like the command line or something like that. And that is all I have. It's a short presentation, but if you have any questions, I'm happy to answer.
Yeah, thank you so much. So lots of different services and standards are kind of involved in this effort. Could you explain a little bit more as to some of the services that Harmony involves for the user end? So for example, what would be a typical application that a user would use Harmony Pi for?
There we go. Yeah, so one of the most typical use cases is subsetting, right? So as I mentioned, like all of our data is in the cloud. Oftentimes it's a lot of data. You don't necessarily want to download it all. You can just use Harmony to access the bits that you want. So if you want variable subsetting, if you want spatial subsetting, if you want temporal subsetting, reformatting, reprojection, those are probably the most common use cases.
Yeah, and so that's all being ran inside of the cloud. And so you don't need to have necessarily an AWS account in order to access those services. And those are being essentially paid for by NASA's end. That would be correct, right?
Yep, that is correct. Mm-hmm.
What are some of the challenges that you've had with that cloud migration and being able to have Harmony integrate with that? Because I believe was Harmony, that project, older than the cloud migration effort?
So that's a good question. Harmony kind of predates my career here at ESDIS, so I wouldn't be able to answer that with certainty. I mean, there have been a lot of challenges. I think one of the biggest challenge is to not just have like a lift and shift mindset, right? Like we have a lot of amazing functionality that the DACs have developed, but if we lift and shift every single service, we're going to end up with a lot of duplication, which is kind of what a reason why we wanted a common platform in the first place, is so that we don't have to duplicate as much and we can kind of collaborate and free up our energy elsewhere. That's probably one of the biggest challenges. Another challenge is like with this paradigm of the cloud and this shared platform. It can be kind of difficult to figure out how to adequately share the resources between users and their requests, right? Like one user might want to like reformat an entire collection, but that's not necessarily fair to other users who want to get into the system and just do like a small subset of a specific collection. So ensuring that those things can run in tandem and equitably is definitely a challenge that people are facing. And similarly, in a similar theme, like making sure that those types of requests that maybe someone even made by mistake because they were playing around with Harmony, like in the cloud, it's very easy to spend and not necessarily have a cap on what those limits are. So those are some of the things that we need to explore more. And I know we've been talking to JESDIS about those types of things as well. I know JESDIS is really into this concept of pure, which we're not as familiar with on Harmony, and that's something that we may look into in the future.
Yeah, thank you. I personally, I'm not really involved as far as JESDIS's effort goes with that kind of pure concept, but what we're really focused on is a lot of those open science principles, particularly when it comes to being able to have users switch around from service to service as they want to do so, whether or not they're working with an older collection. Maybe they're working with comparing level 2 data and level 3 data with co-location and things like that. Something else I wanted to ask you about is, and maybe you could explain a little bit more, is how Harmony works with a lot of the ingest. So how familiar are you with the process for getting the data that's in the on-premises realm into AWS in a way that's efficient?
Yeah. So that's a good question. So uh, I would say that that is not my realm or my expertise, but it's definitely like the limiting factor when it comes to onboarding to these services, right? Like the data needs to be in the cloud, or ideally is in the cloud. But that's definitely a challenge that we've been working through more broadly with ESDIS and at the DAX is how do we quickly get our data to the cloud? It's a massive effort. Yeah.
Yeah, thank you. And I think if you don't mind, I'll go ahead and share my screen. Something I do want to show everybody is the Harmony documentation. So basically, the page that you first see when you Google NASA Harmony Python on Google. And so you're taken to this site, which is harmony.earthdata.nasa.gov. And so I can go ahead and post this in the chat, but I would encourage everyone to take a look at this, especially if they have any sort of experience with Jupyter notebooks, even if that's just, if you're just vaguely familiar with it, I would encourage you to go ahead and look through these. And additionally, this is a service that is not just restricted to Python. So right now at JESDIS, we make a lot of different tutorials. Most of them are dealing with Jupyter notebooks and Python, whether that's data access with things like OpenDAP or not. JESDIS also has their own subsetting service, but that is currently being run on premises. We're trying to get that migrated to the cloud. But it's important to note that it's got a really, really big chunk of documentation for how to request these queries just using tools, for example, like curl. We also, part of this documentation is the Earth data login process. So something I want to really hammer into a lot of the attendees who might not be familiar with accessing NASA Earth data or the services is this concept of the Earth data login. So we show how to do that. We show how to pass in a token. We show how to generate a file called an NRC file that is basically storing your Earth Data login and password. But creating an Earth Data login is free to everyone. And so we have lots of documentation all over the place as to how to do that. And so that's just for reasons of security and metrics as well. But I would encourage you all to go ahead and play around with this and take a look at all the different query parameters that are in place with this. And something else as well is this has some integration with Earth Data Search. Is that correct? So I believe you can make a subset request through Earth Data Search. Yeah.
Yeah, I would consider Earth Data Search as kind of the front end to Harmony. So yeah, like in theory, anything that you can do via Harmony should be accessible via Earth Data Search.
Yes, and that's another tool that I'd like to just go ahead and briefly show. So if you wish to browse any of these collections, of course, nearly 10,000 of them, ranging from reanalysis data, simulation data, for a lot of these, you can find the data region that you would like. And if you wish, you can actually create a spatiotemporal request for that. And it will use Harmony in its backend to go ahead and create that request and send it back to you, which you can download through the browser. I believe that you don't need an Earth Data login to do that, but I think you're limited in the amount of data that you can download to do that. But I'm not entirely sure. But Vinny also brought up CMR, which is the content metadata repository. And so these are all essentially a visual catalog of that metadata repository. And so you can browse all the different collections and see the UMM JSON items that there are for each of them to get all those different data access links. And then additionally, you can also see that not all of these collections have been transferred to the cloud. Some of them are in the process of doing that, but not all of them may be migrated due to the age of them, the size, whatever it might be. And so something to note is that you'll see on the left side, if it supports these spatial subsets, temporal subsets, this is basically saying that this can be run with those Harmony subsets. And you'll also notice that for a lot of those, they happen to also be inside of the Earth Data Cloud, and you can see the badge. But also some of them are in the Earth Data Cloud, and they don't have this spatiotemporal subset. So I can go ahead and post a link to this resource as well in the chat. So we've got still plenty of time left, and I see we've got some participants that I recognize their names from the last time. But something that I'd really like to do with this committee, and I'm not sure if many of you were around at the July conference. I'll go ahead and stop sharing my screen here so that you're not seeing redundant faces here. Something I'd like to do is just kind of open up the floor to anyone who'd like to go ahead and just ask any questions. Or what I'd really like to do is maybe have just a brief background and just see if we can answer any of your questions, whether that be from the NASA data perspective or just from the workflow perspective. So and we have a great opportunity to speak with someone who is very closely involved with that process. The way that it works with NASA is that we've got these kind of different tiers of organization, and ESDIS is one of those higher tiers that kind of governs a lot of the services and the coordination efforts between those different DACs. So I know that we all don't like icebreakers and things like that. I know some of you might not be able to unmute, but if you wouldn't mind unmuting yourself and giving a brief introduction and maybe things that you might be interested about with a service like this, or maybe something you'd like to see more at a future meeting. If you could please unmute yourself, that'd be great. And if people just want to go ahead and put their hands up in the chat, if you're willing to do so, and I can just go in order. Otherwise, I might just do the old-fashioned just calling names, but I understand that some of you might be in juggling some other meetings. And I think if not, something else that I was considering doing is possibly maybe just going through that Jupyter notebook. I'm not going to be able to run that Jupyter notebook. I'm currently on my personal machine, which is designed specific in a Windows environment specifically for demonstration spaces. But I think that would be another great thing to show as if we still got a lot of time left here. So, not seeing any hands up, which is a great sign. So I think, and Vinny, I guess if you wouldn't mind, if I just showed and kind of walked through that Jupyter notebook that was in that GitHub space. I don't want to take up any of your time, but I think it'd be great to show that resource.
Sure.
Cool. So I'll go ahead and share my screen again. And let me put you all in the other window. And all right, can you all see this browser? It says CMR. Okay, great. So let's go over to this NASA Harmony Pi GitHub page. And so you'll also notice that a lot of these different things are being put into spaces like GitHub, into public spaces like GitHub. And that's kind of part of this open science effort that has been involved with NASA Earth Data and the various DACs for the last few years, ever since Directive 41A by the White House. And so I'm really happy to see resources like this that are able to have public interaction with them. Let's say, for example, you have a bug, we have this issues tab. You have the ability to open up an issue if you wish, but usually sources or resources like this are kind of managed through that back end. You'll see a lot of different kind of feature titles that are involved with that. So, but they do have a release schedule here, which showing different versions of the repo that have different capabilities than others. And then another thing you'll notice is that inside of this repo, and I have browsed this repo several times before, is there is this examples folder. And if you go inside this examples folder, there's several different Jupyter notebooks, all showing various ways to utilize these resources as well as some sample data. But if I just click on this basic Harmony Pi workflow example, I think I'll just go ahead and kind of go through this. So let me zoom in quickly. If those of you in the audience are not familiar with Jupyter notebooks, these are basically living code documents where, although they might be in an actual JSON format, it's essentially JavaScript. You have Markdown along with these cells of Python code. And that's really great because you can make tutorials like this or use cases that others can share and be able to easily read and understand it. So I'm really appreciative to those involved with this repo. Tomorrow, I would also give a +1 for the Jupyter notebooks as well. So you can see that a basic workflow install is to install a few different things from this library. But you'll notice that it's not exactly in the same way that you would install it like other Python packages using either pip or Anaconda. You'll see that you have a few different requirements. This requirements examples will install the components to get the Jupyter notebook running. But you'll also notice that we've got this pip install Harmony PY. We also have the ability to just install it directly through the GitHub repository if you wish to clone that. So there's a few different ways to install these things. You'll see that there is this import helper that contains a lot of different helper functions. And then from the Harmony package, you've got your bounding box, your client, and your environment, and so on. In this notebook, you'll see that it's using this thing called UAT, which is user acceptance testing. So that's really just for a lot of, if let's say you're working on testing some services, if you're in the development space, you would have a UAT account, but you do not need to have that in this end environment.uat. I believe the default environment is the regular UUI public facing, or the, not the UUI, the prod environment. And you'll notice that all you need to run that is your username and password, which are going to be stored using this kind of this helper.txt, which will basically just store those in a way without having to put them in an NRC here. And so you'll see that there's this username and this password field, but this Harmony client object does need to be created, and that will help with authentication and also being able to return the subset request to your notebook. But then you'll see as well, in that next cell, there is this field which contains a few different parameters, and one of them is this collection ID. So with all these different collections that are currently being migrated to the NASA Earth Data Cloud, what we've done is we've assigned this unique identifier for each of those collections. So you can search for a collection using a DOI, using a short name, which you might recognize some strings of letters, or you could even use the long name, which will also include the version number. But you can also just use this collection ID. And for most of these collections, you will find the collection ID on the dataset landing pages, or of course using the Earth Data Search. And so what we're doing here is we're basically requesting to specify which ones we want from the collection metadata repository API. And that's another API that has a lot of different parameters, including spatial bounding boxes. You can have the data be returned to you in different formats as well. In this case, it's actually a TIFF image. But these are things that, and thank you so much. I see that you're going to jump to another meeting, so I appreciate it so much. And Gay, I think you have a hand up if you wish to ask a real quick question before he has to leave.
Yeah, can you hear me all right?
I can.
Okay, great. So the collection ID, this particular one, is that the one from CMR? Can you use the DOI? Would that work?
Yes. So that is another way to do it. But for a lot of these examples, sometimes they'll use the collection ID just to be specific without having to specify the DOI and additionally maybe other things like versions.
Okay.
Sometimes
Thank you.
something, yeah, no problem. That's a great question. Sometimes if you just put in a search query with just the short name, that short name may also include different versions as well. Meritu is a good example of that, so that's a great question. But then what you do is you basically submit this to Harmony as a job. And so you set this equal to a variable which will represent the job ID that is running in that Earth Data Cloud, this Harmony client. And you can also view the status of the job, which is great if you are downloading or subsetting large amounts of data. This is also necessary for if you are having a large subset. It can take anywhere from just a few minutes to maybe an hour, depending on the collection. But here we've also got code which will allow you to wait for the job to finish, and then we'll automatically start that download process in a way that is actually parallelized, built in. And you see that described in the markdown. We're actually using concurrent futures or thread pools to download this in parallel. And then you'll see that we have them being downloaded as these default file names into your local directory, but you can also specify the directory that it is. Otherwise, it will just download to where the notebook is. And then you can finally view the results to see all the different files that have been downloaded. The next cell in this notebook is showing a different temporal range. So you'll see that this temporal range is kind of different, how that parameter is being passed in here. You have this date time object, which is what Python uses to parse date stamps. And that's really useful if you wish to use things like UTC coding for searching through hourly collections, for example. And in this case, we are actually setting this request equal to a different job ID. So what that's basically showing is that you can have in one Jupyter notebook all of these different jobs that are running in the cloud, and you can combine all this different subset of data together in just one Jupyter notebook. Really all you need at that point is just time and patience and a solid internet connection to be able to download all of that data once it's done being processed. And then you can see that we will again wait for processing in this cell where we can actually have a verbose parameter to show the progress of it, and then it will download them. So there's a few different ways to do that. They also show how we have a valid request and the errors that you encounter with that. So if you, let's say, set, in this example, a bounding box latitude, longitude that is invalid, we can use this request is valid parameter to throw an error in case something is wrong. And that's really useful because otherwise you may be running this, you may be getting a bit of an unclear error when it returns back to you. But there are plenty of ways to be able to have a service like this involved in, let's say, some other sort of package or Python package, or if it's in your local workflow, to be able to incorporate NASA Earth data, and also things like compute for free into a Jupyter notebook. And that's also really important. Right now, NASA is basically providing all of that through our subsetting services like OpenDAP in the cloud, for example, and that's all being run for free. So then again, there's also code for exception statements to be able to catch those errors. And the notebook also just demonstrates various ways to have different parameters. For example, in this request parameter, they actually have a granule ID, which is to get all the variables from just a single collection. And in this one, you actually have a CRS that they specify along with a height and width and the variables that you wish to grab. That's really great, especially with a collection like this one, which is really just red, green, and blue channels of a lower processing level TIFF image. So you can see there's a lot of different things that Harmony can do, but more importantly, it's being run in the cloud separate of what the user wishes to do. And so, or what separate of what the user would have to otherwise install themselves. For example, if they were to use the OpenDAP service, where they would have to construct those URL subsets, run it through the OpenDAP server, and then hope that there is enough bandwidth in order to do that. And you did hear Vinny touch on that very quickly at the beginning of this presentation, that bandwidth is, of course, an issue. And when it comes to AWS, being able to have those things run in an efficient manner is really important. And then I also wanted to point out, speaking of the cloud, that we have, they have another notebook that shows how to run this using the direct S3 bucket access. So for example, if you have a Jupyter Hub server running inside of the US West 2 AWS region, you just want to pull the data directly from the bucket without having to go through the public internet and download them, you can run this client inside of the cloud as well. And you'll see that the steps to be able to authenticate are a little bit simpler. This one also uses the Photo 3 client to actually download the objects from that bucket. There's a few different ways to do that as well, but they all have Photo 3 in their backend, which is developed by the folks at AWS. Yes, I see another question.
Thank you. Is there a way for Harmony to provide a list of variables and the bounding box of all the data of the collections?
So not through Harmony, but yes, through the content metadata repository. So that's really useful because let's say you have level 2 data, you have these different points. You can use CMR to perform a search that is very similar to the ones that you see here, and it will return to you all of those different UMM JSON objects containing the URLs of the valid files that are inside of those bounding boxes or spatiotemporal requests. So this is using that in the back end, but we also have a Python CMR library that can be used to just generate the URLs if it's in your parameter. So I can also post that in the chat as well. They're currently working on getting it in its own GitHub repository. So this is what that looks like here. You'll see that it's under that NASA organization. If you just Google it, you'll see kind of an earlier iteration of it, but this is the correct one.
Okay, great. Thank you.
Yeah. Oh, and it looks like I was scamming. I can put that in the chat as well. Well, I think if nobody else has any other questions, I see that it looks like a few people have dropped out, so we're just getting past the 45-minute mark. So if nobody has any other questions, and Vinny had to jump out as he is at another meeting, I just want to go ahead and thank him for giving us his time today to show this really valuable resource. And I would also like to announce our next speaker for next month's meeting, which will be Miguel Urias Jimenez. Excuse me, I'm not sure if you all heard me just now, but I was mentioning that we are about 45 minutes past the hour, so I think I'll go ahead and end the meeting here. But I also wanted to thank Vinny for giving his presentation today on this really invaluable resource. And along the same lines of data access and interoperability, I want to go ahead and announce next month's speaker, which will be Miguel Urias Jimenez from the Open Data Foundation. And so that's describing another very widely used tool that I'm a big proponent of, that NASA has worked closely with, but not just NASA, several other organizations as well in the geospatial science community. And so Miguel will speak to us about what the Open Data Foundation is about, how you can access some of their data, and I'm looking forward to seeing you all there again. So if nobody else has any questions, I will go ahead and stop the recording.
Thank you. Bye.
Thank you. Let me go ahead and stop that recording.